T8.12. For some people, mistletoe is a symbol of romance. Mesquite trees, however, have no love for the parasitic plant that attaches itself and steals nutrients from the tree. To estimate, to estimate the proportion of mesquite trees in a desert park that are infested with mistletoe, a random sample of mesquite trees was randomly selected. After inspecting the trees in the sample, the park supervisor calculated a 95% confidence interval of 0.2247 to 0.5753. Okay, so part A, interpret the confidence level. All right, so the way you want to think about the confidence level, sorry to go all the way back here. Let's see, copy. All right, is to think about what would happen if we took many samples. Okay, paste from clipboard, there we go. Right, so 95% means in the long run, if we, make hundreds or thousands of samples and create an interval for each one, then 95% of them will be like these that capture the true value, and then 5% are going to miss. Okay. All right, there was actually a template. Let me see if I can pull that up real quick. It was right here. All right, so let's copy this template. Copy image, screenshot. All right, so if we take many samples and calculate a confidence interval for each, about 95% of them will capture the true, okay, now I've got to add the context here. We're trying to estimate the proportion of mesquite trees in this desert park that are infested with mistletoe. So the true proportion of mesquite trees in a desert park that are infested with mistletoe. All right, so that's part A. Part B, calculate the sample size that was used to create this interval. Oh, okay. So, to figure out the sample size, let's first figure out the margin of error. Now, we can find the margin of error by finding the difference of the endpoints and dividing by 2. Okay, so that'll be 5753 minus 2247 over 2. Okay, 5753, 2247 over 2. Okay, so the margin of error is about 1753. Okay. Now that I know the margin of error, right, let me think back to how the margin of error is computed. Right? It's a critical value times the standard error, which for this situation, that would be square root p hat 1 minus p hat over n. Okay. All right, so I know the margin of error. I can plug that in. The z-score, well, since I know the confidence level, let's look up the z-score real quick. 95%. All right, so the z-score is going to be 1.96. Just make a note. Z-score 1.96. Okay, we don't know the sample size, but that's what the question is asking us to find. Okay, p hat. P hat's the point estimate. Well, we can work backwards and figure out the point estimate. The point estimate is just going to be the midpoint, right, of our interval, right, or just the average of those two values. Okay, we can write it like a plus b over 2, or in this case it's 0.2247 plus 0.5753 divided by 2. All right, and that's going to equal 0.4. All right, so let's start plugging some numbers in. All right, so 0.1753 equals 1.96 times the square root of 0.4 times 0.6 divided by n. Okay, and at this point it just becomes an algebra problem, so we just got to solve for n. Okay, I'm going to go ahead and square both sides. So 0.1753 squared equals 1.96 squared times 0.4 times 0.6 over n, so that square root just gets wiped out. All right, now let's multiply both sides by n, and just to kill two birds with one stone, I'll divide by 0.1753 squared at the same time. So on the left-hand side, those terms will cancel out. On the right-hand side, the n's will cancel out. So now when we simplify the left-hand side, all that's left is n. When we simplify the right-hand side, we have 1.96 squared times 0.4 times 0.6, all divided by 0.1753 squared. And now I'm going to put all of this in my TI-84. Okay, and I get 30.0026 with some other digits, which means that I'm going to round this up, and I'll say the sample size was probably 31.